Today, we're doing Math Analysis, Chapter 2, Section 1, Right Triangle Trigonometry. I'm your host, Dr. D. Okay, now, using special right triangles, we're going to be able to determine the 6 trig functions for specific angles. First of all, we're starting with the famous 30, 60, 90 right triangle. Now, the interesting thing about 30, 60, 90 right triangle is it has a short leg, a long leg, and a hypotenuse. Now, the short leg, we're going to say that's 1 unit. You could call it x or you could call it 1, but we're just going to call it 1. Now, the hypotenuse is always twice the short leg. And the long leg is always the square root of 3 times the short leg. So 1, 2, and the square root of 3 is the ratio of sides. So if the short side was 5, then the hypotenuse would be 10. And the long leg would be 5 times square root of 3. So it's this ratio. Now, it's simplest to just stick with 1 for the short leg always, and then the hypotenuse always twice that, the long leg square root of 3 times that. Now, knowing those sides, we can now get the sine of a 30-degree angle. Because you know sine is what? Right, opposite over hypotenuse. So 1 over 2. So that just told me that sine of 30 degrees is 1/2. And that's always going to be true. Now, cosine of 30 degrees. Now, you should be able to do this a little bit ahead of me. You know what's coming up. Cosine of 30, adjacent over hypotenuse, is square root of 3 over 2. Tangent of 30. Well, that's opposite over adjacent, which is 1 over the square root of 3. Now, we are not like the godless heathen who leave radicals in their denominator. So, we must rationalize our denominators. Okay, so we multiply by square root of 3 over square root of 3. And notice now we have square root of 3 over square root of 3 times square root of 3 is 3. So tangent of 30 degrees is square root of 3 over 3. Now, cosecant of 30 degrees is the reciprocal of sine 30 degrees. So cosecant is going to be 2 over 1. Now, secant 30 is the reciprocal of cosine 30, so that's going to be 2 over the square root of 3. And once again, we need to rationalize the denominator. So we end up with 2 square root of 3 over 3. And then cotangent of 30 is the reciprocal of tangent of 30. Well, it's easier just to reciprocate square root of 3 over 1. So there it is. So we have the sine of 30 is 1/2. Cosine of 30 is square root of 3 over 2. Tangent of 30 is square root of 3 over 3. Cosecant of 30 is 2. Secant of 30 is 2 square root of 3 over 3. And cotangent of 30 is square root of 3. It seems to me that this would be a good thing to memorize.
That's the smartest thing I've ever heard anyone say about anything.
Okay, now, you don't memorize the numbers, you memorize the positions. See, if you did what I told you to do a few weeks ago, and you memorized that sine is opposite over hypotenuse, then when you see the 30, 60, 90 triangle in your mind, then you realize that sine of 30 is 1/2, and cosine of 30 is square root of 3 over 2, and tangent of 30 is square root of 3 over 3. And then you know the reciprocal functions as well. So that's the key thing, is memorize this triangle, and then you'll know all these functions. Okay, now, what if we take our 30, 60, 90 right triangle and put the 60-degree angle on the lower left side? Now, what are our ratios? Well, remember, the short side is 1, the hypotenuse is 2, and the long leg is 3, or square root of 3. So now, the sine of 60 opposite over hypotenuse. That's square root of 3 over 2. Cosine of 60 adjacent over hypotenuse, 1/2. Tangent of 60, square root of 3 over 1, opposite over adjacent. Now, when we do the reciprocal functions, we realize cosecant of 60 is a reciprocal of sine of 60. So that means we have 2 square root of 3 over 3. Secant of 60 is 2. And cotangent of 60 is 1 over the square root of 3, which is square root of 3 over 3. So now we know all trig functions of 60 degrees. All right, now we take our next special triangle, and it's a 45, 45, 90. Now, this one, since the base angles are congruent, then that means we know these two sides are also congruent. So we have the legs of the 45, 45, 90 right triangle are 1 each. Now, the Pythagorean theorem says that a squared plus b squared equals c squared, so that means 1 squared plus 1 squared is 2, and so the third side, the hypotenuse, needs to be the square root of 2. So this is our 45, 45, 90 triangle with 1, 1, and the square root of 2. Once again, if, let's say, the base was 15, then it would be 15, 15, and 15 square root of 2. Okay, now, the sine of 45, opposite over hypotenuse, 1 over the square root of 2. That becomes square root of 2 over 2. Cosine of 45, adjacent over hypotenuse. Well, notice sine and cosine are the same because the opposite and the adjacent sides are the same. So cosine is square root of 2 over 2. Tangent 45 is 1 over 1, which is 1. Now, cosecant of 45 is the reciprocal of sine 45. And remember, sine 45 came from 1 over the square root of 2. So when I reciprocate that, I just get square root of 2. And secant of 45 is also square root of 2. And when I reciprocate 1, I get 1. Cotangent 45 is 1. All right, so let's look at all the stuff you know so far. Okay, so you should be able to fill these out on your own right now. So I'm going to fill them out, but I would suggest you turn the camera off, do it yourself, and then come back and see if you got it right. Okay. You didn't turn the camera off. Turn the camera off. Okay. All right, welcome back. Okay, so 0 degrees. Well, remember, we need to look at our quadrantal angles. So 0 degrees is out here. Well, sine of 0 is the y value at 0. What is that? It's 0. So, yeah, we'll go with red here. So, sine of 0 is 0. Cosine of 0 is the x value at 0, which is 1. Tangent of 0 is y over x. So it's 0 over 1, which is 0. Now, cosecant of 0 is the reciprocal of 0, which is undefined. Secant of 0 is the reciprocal of cosine, which is 1, and cotangent is the reciprocal of tangent, which is the reciprocal of 0 is undefined. Now, when we go with 30 degrees, sine of 30, 1/2. Cosine of 30, square root of 3 over 2. Tangent of 30 is square root of 3 over 3. Cosecant of 30 is 2. Secant of 30 is 2 square root of 3 over 3. And cotangent of 30 is square root of 3. Sine of 45, square root of 2 over 2. Cosine of 45, same thing. Tangent of 45, 1. Cosecant of 45. Secant of 45, cotangent of 45. Okay, sine of 60, square root of 3 over 2. Cosine of 60, 1/2. Tangent of 60 is square root of 3 over 1. Cosecant of 60 is 2 square root of 3 over 3. Secant of 60 is 2, and cotangent of 60 is square root of 3 over 3. Notice when I'm doing this, I'm looking at the triangle in my mind, and that's what you want to be doing too. So now, 90 degrees. Well, remember, that's straight up. So 90 degrees, the sine is the y value straight up. Well, the y value straight up is 1. Then the x value straight up is 0. The tangent is y over x. So it's 1 over 0, which is undefined. Then cosecant, we just reciprocate tangent, or reciprocate the sine, you have 1. The secant, you're reciprocating 0, so this is undefined. And then cotangent, we're reciprocating undefined, which is 0. Or basically x over y is 0 over 1. Okay, now 180. Remember, that's over here. So sine, the y value is 0. The x value is -1. Tangent, which is basically sine divided by cosine, which is 0. Then cosecant is undefined. Secant is the reciprocal of -1, which is -1, and tangent of 180 is undefined. Wait a minute. Tangent 180. Yeah, y over x. Okay. And x over y is -1 over 0. Okay, so that's it. Now, 270 is straight down. So the sine is -1. That's the y value straight down. Cosine is 0. The tangent is sine over cosine, which is undefined. Now, cosecant, reciprocal of -1 is -1. Secant, reciprocal of 0 is undefined. And cotangent is 0. Now, 360 is going to be the same thing as 0. So it's going to be 0, 1, 0, undefined, 1, and undefined. So, like I said, these are stuff you know. I should say, this is stuff you know. So, you need to visualize each one of these triangles and know your 6 trig functions of each one. Okay, cruising onward. Cofunction relationships. You may have seen that if you're observant back here. Notice that sine of 30 and cosine of 60 are the same thing. And sine of 60 and cosine of 30 are the same thing. Why is that? Well, let's take a look. So if we take our 30, 60, 90 right triangle and we look at the lengths of the sides. So remember, the short leg is 1, the long leg is square root of 3, and the hypotenuse is 2. Well, if I look at sine theta, that's going to be 1 over 2, because opposite divided by hypotenuse. Now, if I look at the 60-degree angle, the 1 is now the adjacent side. So from the 30-degree angle, 1 is opposite. From 60 degrees, 1 is adjacent, and they have the same hypotenuse. So what that says is that sine of any angle will be cosine of its complement. So sine of 30 equals cosine of 60. Sine of 60 equals cosine of 30. Sine of 45 equals cosine of 45. Sine of 40 will equal cosine of 50. Sine of 70 will equal cosine of 20. So that's how the cofunctions work. Now, likewise, cosine of any angle will be sine of the complement of that angle. Now, notice the tangent relationship. Tangent of 30 is 1 over the square root of 3. Well, tangent of 60 is also, cotangent of 60 is also 1 over the square root of 3. So tangent and cotangent have that same relationship where tangent of 70 equals cotangent of 20. Or cotangent of 30 equals tangent of 60. Now, because sine and cosine are cofunction relationships, secant and cosecant are as well. So secant of any angle will be cosecant of the complement of that angle. Now, that's just one of those things that you want to keep in your mind. So anytime you're given a sine value, you know the cosine value. So we've got sine and cosine matched, tangent, cotangent matched, and secant, cosecant matched. Now, we're given a triangle ABC, and we're told that side A is 20 and side B is 15. So, what's 20? Well, it's the opposite side of angle A. So here's our 20 right here. And then side B is 15. That's the opposite side of angle B. Now, what they want us to do is put the triangle in standard position on the coordinate plane. Okay, well, here's our coordinate plane. Here's our x, here's our y. Now what we want to do is we want to put the right angle coming up from the x-axis. So that means what we're going to do is we're going to rotate this triangle around like this, and C is going to be here, and yeah, it's going to go up 20, and here's the 15. And here is up. Here is the right angle, and notice the right angle is C. So that makes this is B, and this is A. So notice side A is 20 and side B is 15. And so the point at B is the ordered pair 15, 20. So we put the triangle in standard position, which means it's opening up at the origin, and the coordinate of angle A is 0, 0. Angle A is going to be 0, 0. Angle B is going to be 15, 20. And that's actually the coordinate that they intended you to. If I had named these angles correctly, they actually wanted the coordinate of B. So that's it, cruising onward. Now, given that the cotangent of 75 degrees is 2 minus the square root of 3, we want to find the exact value of tangent squared 15 degrees. Now, here's the thing. We're given that cotangent 75 is 2 minus square root of 3. In a little while, we'll be able to calculate that on our own. But what we know here is cotangent of 75 equals tangent of 15. Because remember, cotangent and tangent are cofunctions of each other. So cotangent 75 equals tangent of 90 minus 75. Okay, so what we have here is 2 minus square root of 3 equals tangent of 15 degrees. All right, now, we don't want tangent of 15 degrees. We want tangent squared of 15 degrees. So I square both sides. So tangent squared 15 degrees equals 2 minus square root of 3 squared. So this is our a minus b quantity squared. So it's a squared minus 2ab plus b squared. So it turns out to be 4 plus 3 is 7 minus 4 square root of 3. So tangent squared 15 degrees equals 7 minus 4 square root of 3. Piece of cake. Basically, all they're doing here is testing to make sure that you remember that cotangent and tangent are cofunctions of each other. So they could have said, given cosine 70 degrees, or 75 degrees, and ask you for sine squared of 15 degrees. Same idea. Okay, one last game here, and that is we're going to be given that alpha and beta are complementary angles. So we need to verify these identities, just like we did last section. Okay, so we need to verify that cosine squared alpha equals 1 minus cosine squared beta. All right, so what I can do is I can change the, there's a bunch of ways we could do this. We could use the Pythagorean identity that sine squared plus cosine squared equals 1. So that means if I subtract cosine squared from both sides, then I have sine squared equals 1 minus cosine squared. Now this works with any angle. So basically what I know then is sine squared beta equals 1 minus cosine squared beta. Well, there's my 1 minus cosine squared beta, so that equals sine squared beta. So cosine squared alpha equals sine squared beta. Now, I know that cosine squared alpha is really cosine alpha squared, and sine squared beta is really, let's just leave it sine squared beta. Now we'll do that over here too. Okay, so the next thing I know is that sine and cosine are cofunctions. So that means cosine alpha equals sine of 90 minus alpha. Remember, alpha and beta are complementary angles. So that means cosine alpha equals sine beta, because beta equals 90 minus alpha, because alpha and beta are complementary. So if cosine alpha equals sine beta, then what I could do here is just substitute a sine beta where I see the cosine alpha. That's it, game over. So it's really pretty simple. You just have to realize with sine and cosine being cofunctions, and you have your Pythagorean theorem, that it works out pretty easily. Okay, let's try one more. Okay, now we have arrived at maximum juice. Okay. We need to verify that sine squared alpha times tangent squared beta plus cosine squared beta equals 1. Now, one thing I'd like to show you before we get started is this simple identity that sine theta equals y over r, and cosine theta equals x over r. So sine theta over cosine theta equals y over r divided by x over r. Now, if I flip the bottom and multiply, then I have y over r times r over x, which equals y over x. Now, we know that y over x equals tangent theta. So what we just found out is tangent theta equals sine theta over cosine theta. Now, we don't need this identity for verifying this, but it comes in handy. So I'm going to use this. All right, so first thing, I'm going to change the alpha into a beta, because we have all betas, so it's easier to change sine squared alpha into cosine squared beta. See, we know that sine of alpha equals cosine of beta, so sine squared alpha equals cosine squared beta. All right, now notice we're going to use the cosine squared beta over 1 times tangent beta, which is sine beta over cosine beta. All right, now the cosines cancel, and I'm left with sine squared beta plus cosine squared beta equals 1. And we know that sine squared plus cosine squared equals 1. And that's it, QED. Have fun with these.
That's all, folks.